Imagine a massive software project delivered perfectly on schedule. The architecture is elegant, the system operates with zero latency, and every line is bug-free. But when the client finally reviews the system, they reject it. It works flawlessly, but it fails to solve the problem they actually had. This happens because many developers are biased toward action. When a project starts, the instinct is to begin coding immediately, assuming that the necessary details will simply become clear as the work progresses. Software pioneer Fred Brooks identified this trap decades ago. He observed that the hardest part of building a system isn't the coding itself, but the act of deciding what to build in the first place. Building an elegant solution to the wrong problem is a total failure. To avoid it, engineers must prioritize the requirement analysis phase before a single line of code is written. This phase addresses the translation gap, the distance between a vague human need and rigid digital reality. Bridging that gap requires distinguishing between the customer, who funds the project and sets business goals, and the end user, who will actually operate the software. If engineers listen only to the customer while ignoring the end user's workflow, they risk building a system that is technically sound but practically useless. This chart illustrates the stakes. It tracks the cost of change against a project's timeline. Early on, catching a misunderstanding is cheap. Just update a document. But if discovered after deployment, the cost explodes. You're tearing out finished code and redesigning the foundation. Relying on user feedback only after the software is finished is an expensive and mathematically documented path to project failure. The antidote is requirements engineering, a methodical process for defining exactly what a system must do. It starts with inception and elicitation. Engineers interrogate the reasons behind a request, parsing out vague desires to find the technical requirements that can actually be built. Then comes elaboration, where the team creates use cases. A use case maps a user's interaction step by step. It focuses entirely on what happens in the real world, translating a messy web of human requests into a linear logic path. Finally, through negotiation and validation, stakeholders resolve conflicting desires. They ensure the blueprint matches their actual needs before the first line of code is written. This transformation turns a chaotic wish list into a binding, verifiable plan for construction. This process changes how we define software quality. It moves beyond quality of conformance, simply writing code that doesn't crash, to the necessity of building useful products. True quality is found in quality of design, the measure of how well a system actually satisfies its users. This precision is necessary because we now rely on software to manage complex, large-scale systems. When an application controls a logistics hub or a commercial network, a misunderstanding in the requirements becomes a systemic risk. Because the consequences of failure are so high, technical proficiency alone is no longer enough. An engineer's ability to communicate, empathize, and rigorously define a human need has become as critical to a project's success as the code itself. Before you begin building your solution, make absolutely certain you are solving the right human problem.